Alright, this is the video for Year 12 Maths. We are doing the teaching so that you can attempt exercise 3D. Definite integrals. So this is one of those things where we define the process and then after we have a look at the application for it. So what we've been doing so far is indefinite integration, where we had the integral of some function of x with respect to x, and you get, you add on your c or you find your c and anything like that. Indefinite integration. This is definite integration. Definite integration has limits. You go between two values, for example 1 and 2, so these are called the limits, and they are x values, and it will make more sense in the next section when we actually use the definite integration. But let's say I'm going to integrate 3x squared with respect to x between 2 and 1. This gives me a number, an actual value. Indefinite integration gives me a function. This gives me an actual value, and because it's a numerical thing, I can actually use my calculator. My calculator has an integration button. I'm sure you can find it, and of course that's quite a useful function. That's quite a useful thing from the calculator to check our answers, but it doesn't mean we're not to understand what's happening when we do my definite integration. So the process is this. In square brackets, I leave my limits there and I integrate the function. Remember, you increase the power, divide by the new power. So this will be x cubed because it's 3x cubed divided by 3. So you integrate, leave the limits in, then you evaluate at the top limit, you evaluate at the lower limit, and you subtract one from the other. So 2 cubed minus 1 cubed, which of course is 7. Now at the moment that value is meaningless to us, and that's fine, we'll address that later. But these are the processes. Given the question, or set up the integration, integrate, leave your limits in, evaluate at the upper limit, evaluate at the lower limit, and subtract. So let's look at example 7. Integrate between 0 and 1. The function is x to the third minus 1 squared. Well, at the moment we know nothing other than expanding that bracket, so I shall do that. 0 and 1, x to the 2/3 minus 2, x to the third plus 1. I quite like teaching via video for this reason. You can pause the video and check that you understand that that's correct. It is, but worth going through the exercise of expanding that yourself. Then I'm going to actually do the integration. So 2/3 add 1 divided by, add power, 5/3 divided by 5/3, 2x to the 4/3 divided by 4/3, and then 1 just integrates to x. Now what's interesting here is I haven't put a plus c, and of course that's because when I sub in my 1 I'm going to get blah 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 blah. If I put in a plus c, I'd get 1 da 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 plus c, and when I put in my 0 I'd get 0 da 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 plus c. So the c's would cancel out. So with definite integration we don't need a plus c because the c's cancel out. Let's just simplify this. So I've done the integration, I haven't subbed my limits in yet. 6/4, so that's 3/2. I can just squeeze onto the bottom of the page. Now I sub in my 1, well that's 3/5 minus 3/2 plus 1. Sub in my 0, which of course will just give me 0, and I should do it on another line, but I'm just going to fit this onto the bottom of the page, 1/10. Now it's not unreasonable to use your calculator to do the subbing in, or indeed to do the subtraction. What you need to show when you set these out is that you understand the process. So you understand that you integrate, simplify, sub in the upper limit, sub in the lower limit, subtract. Of course you use your calculator to do the actual arithmetic. You're just showing that you know what to do. Example 8. It tells us that this integral 2px plus 7 with respect to x, it tells us that it's equal to 4p squared. Show that there are two possible values for p and find these values. So I'm going to end up with a quadratic. Well, given that p is constant, I'll integrate square brackets between 5 and 1. So 2px, integrate, so increase the power divided by the new power. So 2px squared over 2, that's px squared. 7's going to integrate to 7x. Sub in my upper value, 5p times 5 squared, 25p plus 7 times 5 is 35. Sub in my lower value, p times 1 squared, that's p, sorry I should have said with a capital P, plus 7, and that equals 4p squared. 25p minus p is 24p. 35 minus 7 is 28. So I have a quadratic, so let's write it out in the order that I like. Before I do anything, these are all multiples of 4. No, they're not, multiples of 2, so let's simplify. 2p squared minus 12p minus 14. In fact, I can go again. P squared minus 6p minus 7. Oh, that looks like it will factorise. I'm guessing it's 7 and 1, so let's do that. So that equals 0, therefore p equals 7. P equals minus 1. Now the question says something like, show that p has two values and find them. Done. Okay, that's it. Have a go at 13D, please. Let me know if you need anything. See you next time.